So let's talk about the end of the Mesozoic. So in the end of the in the Mesozoic in general, today we can find lots of energy resources. Question 51 from the Mesozoic. There's a lot of materials that we use that originated in the Mesozoic. For example, gold. Gold, copper, silver, zinc. A lot of this material was put into place by those very large batholiths that you saw come in during the Mesozoic. So as those batholiths intruded and started to cool down, we start to see a lot of deposits of precious metals, which obviously here, this is the Bingham Canyon copper mine. This is a giant hole right inside the earth mining out those coppers. Also lots of diamond. A lot of the South African diamonds came up during this time as well, came up during the Mesozoic. And as we saw, lots of salts and lots of sulfur in the Gulf of Mexico, right? All those big salt domes. We also get lots of nuclear fuels in place at this time, lots of uranium. The most radioactive state in the United States is Wyoming. If you were to pretty much hike anywhere in Wyoming with a Geiger counter, it would go off most of the time, right? There's lots of uranium in place all over. And most of that uranium is originating in volcanic ash. So as those volcanoes are erupting right way out in the west, it's washing over lots of uranium all across the continent. And of course, lots of fossil fuels as well, right? As those organisms that were put in place in the Mesozoic are decaying and getting compacted, they're turning into fossil fuels. And of course, coal is definitely one big fossil fuel that we see here. This is a really common coal deposit from the end of the Cretaceous. And of course, as we saw all over the Gulf of Mexico, lots of oil and gas put in place, especially as those salt domes, right? As that salt starts to move upwards towards the surface. Now, what happened at the end of the Mesozoic? Obviously, there was a very large extinction, right, that occurred at the end of the Mesozoic. So we're moving here into question 52 and 53. So what we see at the end of the Cretaceous is that there's a huge mass extinction, and about 25% of organisms go extinct, which is a pretty big mass extinction, right? We would definitely freak out if this was happening today. And we see both animals on the land and in the sea were affected, right? So on the land, what we actually see is even land and the sea, is any animal over 50 pounds goes extinct. So we see all of our dinosaurs, our pterosaurs, our ammonoids, marine reptiles, rudis, they all go extinct. And then down here we see a list of organisms that almost went extinct. They came very close to biting the dust on the end. So what happened? Right? Like I said, only animals less than 50 pounds lived. Now there's a lot of hypotheses that try to explain what happened. Remember, there was a lot of things going on in the Mesozoic. We definitely have climate change, right, that we see as Antarctica is moving on to the pole. We definitely have the Atlantic Ocean that's starting to open. We have new plants coming around, changing carbon dioxide and oxygen levels. There's a lot of things going on. So there's a lot of hypotheses. However, there's one very common hypothesis. And I actually do a lot of work at the end of the Cretaceous. Most of my work up in North Dakota is on the Cretaceous tertiary boundary, right where the dinosaurs go extinct. And the common thought is that there was a very large meteorite impact that occurred at the end of the Cretaceous. And we actually, and the reason why, okay, is we didn't find the crater or the meteorite at first. What we found was this element called iridium. And we find it everywhere you see these little red dots on this diagram. And I want you to notice that one. That red dot is right where my fieldwork, there you go, right there, that one. That's right where my fieldwork is. But we find this element called iridium. And iridium is an element, right? It's on the periodic table. However, it's a very rare element. We only find it in meteorites or in volcanic eruptions. But what we find is we find iridium all around the world, right, at this time. So there's something that had to have happened that blew all this iridium up into the air and kind of made it encircle the Earth. And that's where this thought was that maybe there was an asteroid, right, that hit the Earth. So we had to look for a crater. And lo and behold, right here in the Yucatan, right, if you go down there for spring break, you might see this structure if you really want to go look. And this is called the Chicxulub structure. It's a large crater that dates back to 65 million years ago. So what does this look like in the rock record? Well, what's actually pretty cool is, so what happened is this large meteorite impacted, it impacted the ground, and as it impacted, it threw all this material up into the air, and all that material encircled the Earth, and we get this deposition. So this is what the KT boundary looks like. I apologize, my landlord is cutting the grass outside the window. But this is what the KT boundary looks like in North Dakota. So down here, this is the Cretaceous. Up here, right here is the Iridian layer, and right here is the Tertiary. So here we have dinos, here we have no dinos. Right? So in this layer, what we see is lots of iridium, and if you look, you can see these little round balls in there. Those are spherules. Those are shocked glass that, as that meteorite hit, right, it essentially melted and solidified all this material that got thrown up in the air. So we have these little balls of glass that gets deposited. Now, I actually have done some pretty cool work on this. I've published quite a few papers. However, there was one that got a little bit of press where I looked at the after effects of the asteroid impact theory. So if you want to learn a little bit more about some of the research I do, you can go ahead and Google it. There's a whole bunch of stuff that's going to come up. I got my 15 minutes on CNN and the Discovery Channel and all sorts of stuff. So you can take a look, and there you go. There's the end of the Mesozoic.